Hello, Stats class. This is lesson 4.2d, experiments and what could go wrong. And specifically, we need to talk about some weird things that happen with people. When you have human subjects, there are some problems that could happen. Or one main problem, actually. There's a little bit of a Star Trek reference in this subtitle. Hope you noticed it. If not, I'll tell you. The Trouble with Tribbles is a famous Star Trek episode. You should go look it up sometime. It's very funny. So when you have human subjects, some of the problems that could happen, and the main problem that I want to talk about is the placebo effect. And I put a little video separate from this one on, I don't know yet if I'm going to put it in the Desmos or on Canvas separately, but I hope you watched that already. But placebo effect happens when people are given a treatment and they think they feel better. It's a psychological thing. Even if the treatment does nothing medically. So lots of examples of that in real life. Dumbo and his feather, where he thought that he needed the feather to fly. Little kids where you kiss their owie and they think that it feels better because they got the kiss, that sort of thing. And it really happens in medical studies also. So because of that placebo effect, we need to pay attention to that and work on fixing that. So the wrong way to do these things is to take your volunteers and randomly assign them to two groups, and you give one group the drug that you think will work. And the other group, which is the control group, gets nothing. And that's not what's wrong with it, but if they know they're getting nothing, that causes problems. Because when you compare the results, then the placebo effect would apply to these people because they know they're getting a drug and they know that you think it's going to make them feel better. And then the control group knows that they're not getting anything, and the placebo effect becomes a confounding variable. So what scientists and medical researchers know what to do, they do it the right way, which is they give half of their people the drug, and I'm not going to write that out again, drug that they think will work, and then they give the other half a placebo. So placebo has two meanings. It's the placebo effect, which is they think they feel better, but the placebo is the solution to that problem also. The placebo is a fake drug that looks like the real drug, so that the people getting the treatments don't know which group they're in. And then you compare. You have to trick them into thinking that they're getting something that will work so that the placebo effect applies to both groups, and then it's not a confounding variable anymore. So there are a couple of different solutions to this, and actually they all kind of go together. Solutions to the problem. The control group gets a placebo when possible. Now, it's not always possible, and I'll tell you that right now. Imagine if the treatment is a surgery. Are you really going to take the people who didn't get assigned to the surgery group, and are you going to put them under anesthetic and cut them open and leave a scar so that they think they had the surgery? That doesn't make sense. That doesn't seem very ethical because all kinds of complications could happen from that. So probably they wouldn't do it that way. But I have seen studies that are not pills that use a placebo. Like, for instance, there was one that I read about where they were trying magnets to see if it would reduce joint pain or something like that. So they had to hold this magnet against their hurting wrist or something. And you could do metal that's not magnetic and give that to half the people and make them hold it there, and that would be a placebo. So there's lots of ways to do it, but sometimes it's not possible. The surgery is the best example I can think of that. So if it's possible, you give them a placebo. And then really, really important is you don't tell them which group they're in. And that's called a blind study. The people in the study are blind in that they don't know whether they're in the control group or the placebo group, and that's why it works. If you do tell them which group they're in, it really doesn't work. And then even better than that, if you can, it's best to don't let anybody who interacts with the subjects know which one is which. So the researcher, of course, has to know, but the doctor or nurse or whoever it is that's dispensing the treatments wouldn't know which treatment is which. And the reason for that, let me finish writing it first and then I'll say the reason. Which is which. The reason for that is that you don't want them to subtly give it away with body language or things like that. They might act without even being aware of it. They might treat the people differently that they know are getting the real treatment compared to the placebo. So if you can manage that, it's called double blind. And sometimes it's possible, sometimes it's not possible. But if it's possible, you do double blind. So you always have a control or comparison group. So you either need a comparison group, which would get a different drug or the old drug that we've used forever, or if they're getting nothing, you give them a placebo. So that you can compare what happens if they have it versus what happens if they don't. And if it's a control group, give them a placebo if possible. And then blind and double blind if possible. And they have some fun examples in your homework where you'll have to say if it's possible or not and how would you do it and that sort of thing. And then the last thing we need to talk about today, this is going to be shorter notes, I guess, but that's okay. The last thing we need to talk about is the types of conclusions or inferences that we can make depending on the type of study. And that officially is called the scope of inference. How much of a conclusion can we make? And I'm going to make a little table for this, where we say there are two things you could do to randomize. You could do a random sample. So we're going to kind of combine 4-1 with this. Or you could do a biased sample. Non-random would be the same as biased. And then in the other direction, you could do randomly assigned treatments. Or you could just not. No random assignment. And depending on which box you're in,